Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the isometric projections of the combination of solids. In this problem statement, we have a sphere of diameter 30 mm resting on a frustum of a hexagonal pyramid of base 30 mm, top face measuring 18 mm, and of height 50 mm such that their axes coincide. So here we need to understand the two concepts, that is the type of solids that is given and the way in which they are resting. So here we have got a combination of a sphere and a frustum of a hexagonal pyramid. So the dimension is the diameter of the sphere is 30 mm, while the hexagonal pyramid is having a height of 50 mm and the top face of the frustum measures 18 mm, while that of the bottom face, that is the base of the pyramid, measures 30 mm. And also they're resting in such a way that the axis of the sphere and the axis of the frustum of this hexagonal pyramid are coinciding. So we need to draw the isometric projection of the combination of the solids. However, here the condition is not told like how the hexagon is resting. Either you can take the hexagon resting on one of its corner, or you can take the hexagon resting on one of its edges. But the only thing is the axis of the sphere and the hexagon must coincide. So now we'll consider to construct the hexagon resting on one of its corner. So for that, let us draw the orthographic projection first, and then we can move on to the construction of the isometric projection. So first let us begin the orthographic projection by constructing a line of length of any arbitrary length, but the thickness will be equal to 0.18 mm. So that is the reference line. So now let us go for considering the construction of the top view of the combination of the solids. So let us construct the hexagon. So the hexagon is measuring 30 mm followed by 30 and the angle being 60. Next 30, the angle is 120 or 60 into 2, followed by 30 again and the angle is 60 into 3 or 180 degrees. Next 30 and the angle is 60 into 4, that is 240, followed by the final angle, that is 60 into 5 or just minus 60 degrees. So this is the first part of the hexagonal pyramid, that is the base of the hexagonal pyramid. So now he tells very clearly that the top face is measuring 18 mm. So for this, what we can do is let us construct the triangular faces of this particular pyramid. So it is nothing but joining of the opposite points of the edges. So now we get the triangular faces. Now let me select the offset option, and then or we'll consider constructing the hexagon, one more hexagon of length 18 mm. So offset can also be done, or we can follow this method. 18 and the edge length is 18 again, followed by the angle of 60, followed by 18 and the angle being 60 into 2, that is 120, 18 mm and the angle being 180, followed by 18 and the angle being 60 into 4, and next 60 into 5. So select this, draw the diagonals, and then select this entire hexagon. Go for the move option, ensure the copies of. Select the center of this hexagon and coincide this with the center of this previous hexagon. So you get the top face. So now just go for selecting this hexagon again and change the thickness to 0.50 mm. So this is visible to the observer. So also these are the this is the frustum of the pyramid. So these slant edges will be visible. So let me go for the line option again, 0.50. So all these slant edges shall be made visible. So this completes the first solid, that is the frustum of the hexagonal pyramid, whose bottom face is measuring 30 mm and the top face is measuring 18 mm. So this is the parameter that is given to us. Also, he tells that the axis of this frustum of the hexagonal pyramid, and the sphere is coinciding. So in the top view, we'll just see a circle on the hexagon. So for that, go for the circle by center point. So select the line of thickness 0.50 and then draw a circle of diameter 30 mm because the sphere is having the diameter of 30 mm. So this is the top view of the combination of the solids. Go for the line option, select the line of thickness 0.13, and let us complete the front view of the combination of the solids. So first let me draw the projection lines from the front view. To get the front view, let me draw the projection lines from the top view. So let me select the base of the pyramid first. So this is the base of the pyramid. Also, here I'll be getting the top face of the hexagonal pyramid. And this is the center of both the solids. So let me draw the center line first. Select the center line. So the frustum of the pyramid is measuring uh, 50 mm. So let me draw initially a line of length 50 mm and then complete the front view of the frustum. So go for the line option. Select a continuous line of thickness 0.50. Let me draw the base of the pyramid first. So this is the base of the pyramid and also the top face of the pyramid. So from this point to this point. So this completes the top face of the pyramid. So it has to measure somewhere around 36. So 18 on both the sides. So let me join this opposite corners so that I get the slant edges. And then this is the lower portion of this pyramid which has to be coinciding with this part of the pyramid. So from here I need to extend this. So let me just use the extend to next option. Extend these lines. And then go for the line option again. So from here I'll be joining the slant edges of the pyramid like this, so I get the front view. So I can use the trim option, trim this portion. So this is for the circle that we have considered. So this forms the line for the circle. So let me just redo this front view. Select the line option again. So from the base, join this to this part. So this was the line for the circle, that is the sphere, and this is for the pyramid. So you can just see that the endpoints are not meeting properly. So just let me delete this. Select the endpoint of this projection line and coincide this with the endpoint of this line. So this is the actual front view. So let me select the trim option now. So this line is used to draw the circle. So from here I need to draw the center line again for the sphere. So select 0.13 and select the center line. So the sphere is having a diameter of 30 mm. So the radii will be equal to 50 mm. So now select 0.50 continuous line. Go for the circle. So this is the center point of the circle and the diameter of the circle shall measure 30 mm. So if you just see, if I use the extend to next option, you can just see that it is exactly the point where the diameter of the circle will be seen in the front view. So this is how I complete the orthographic projection of the combination of the solids. So go for the smart dimension. So here I can show the diameter of the sphere which is equal to 30 mm and also the height of the frustum of the pyramid which is equal to 50 mm. So this is the dimension that I require to construct the orthographic projection. So before we start the isometric projection, let me just annotate the axis as x and y. So this is the reference plane, and the planes as VP and HP. So this completes the orthographic projection of the combination of the solids. So now it is time for me to construct the isometric projection. So the steps are very simple. I need to enclose this hexagon, the outer hexagon and the inner hexagon in a square or a rectangle, whatever it is. And I need to draw the isometric projection of that dimension, mark the points 1, 2, 3, 4, 5, 6, and then complete the hexagons. And also the circle should be enclosed in a square again, and then it has to be completed. So let me just use the trim option. So these lines are not required for me, uh, or rather they were required to draw the points where these edges are meeting, so you can just retain them. So this is how the orthographic projection is done. Let me go for the line option, draw the rectangle or the square to enclose the hexagon. So select blue color line, go for 0.13, and let me just start from this. So enclose this complete solid within a circle, or within a square or a rectangle. So this particular square or rectangle, I'll be using it to construct the outermost uh, hexagon. Let me go for the smart dimension. So it is 51.96, and also let me measure the width. So this is a rectangle of dimension 60 cross 51.96. So when you see this, you can understand that I need to construct a rectangle of 60 cross 51.96 even in the isometric sheet. So let me select a line. Let me select black color, draw a line of any arbitrary length. So from any arbitrary point, either I can start with 60 or 51.96, but only thing is you need to know which points you're going to mark. So let me start off with 60 mm at an angle of 30 degrees, and then 51.96 at an angle of 150, followed by 60 again at an angle of minus 150, followed by 50.96 at an angle of minus 30. So I've got this rectangle constructed on the iso sheet. So in the isometric sheet, how we consider is we will draw a line covering 6 boxes and approximately 5.2 boxes. So now go for the distance between. From this point to this point, it is 25.98. Similarly, from this point to this, it is 15. So it is symmetric. So 15, 15, and these are the points. So on 16 mm line, let me select the line option now again. So this is 60, correct? So here, let me draw a line of length 15 mm. So I get 1 point. Select the line option. So on 60 mm, mark 15 mm line from this corner 15 mm, correct? Similarly, repeat the step on the 60 mm line again. So this is 15 and this is 15. So let me just keep the midpoint off until I get this hexagon. So now we'll consider this 51.96. So we will draw a line at the midpoint that is equal to 25.98. Similarly here 25.98. So now let me complete the hexagon. So I've got this point and this point, and here back to these points. So I get the hexagon now. So this is how I complete the isometric drawing of the hexagon. So now again I'll go for the line option, draw the diagonals of this rectangle. So obviously they'll not be meeting properly like 180-degree line. So from the center point of this rectangle, I need to draw the height of the frustum of the hexagon, which is measuring 50 mm. So 50 mm. So ISO scale 50, that is 5 boxes. So from here, I need to construct one more rectangle or a square to get this top hexagon. So let me go for the isometric projection. Go for okay. So one thing we can consider here is to understand. I'll just change the color of the square to blue so that you'll understand I've constructed the blue square, which is drawn here in the ISO, in the orthographic view. So this is the rectangle that I've drawn here. So now let me enclose this hexagon in a different color rectangle or a square. So let me select say dark green. So from this point to this point, enclose this hexagon in a rectangle. So in the IntelliSketch, if you've got this alignment indicator on, you get those alignment points. So go for the smart dimension. So this is measuring 31.18, and also the distance between this and this is equal to 36. So again, I need to construct a rectangle of length 36 and 31.18. So again, take this reference. So 51.96 is this side and 36 is this side. So I need to have edge of 36 dimension here, and then 31.18 here, that is parallel to this line. So I need to construct the line. So let me consider this constructing the rectangle. So here I need to have uh, the midpoint is 18 at an angle of minus 30. Similarly, 18 at an angle of 30, and here again 18 the angle of minus 150. So parallel to this. So similarly here, let me consider drawing a straight line of length 31.18 mm at an angle of 150, and here 36 at an angle of 30 degrees, and then complete this. So now I'll be going for marking these points. So that is uh, the midpoint of 31.18 and also the distance between this. So go for the distance again. So this corner and this corner, it is equal to 9, and similarly this and this, the distance will be equal to, or rather this point and this point, so it is equal to half of this 31.18, correct? So go for the line option. Let me draw it using the black line. So this is 36. So here let me draw 9 mm. So I will be getting these points. So this is 9. Again 9 mm, correct? So the midpoint of this line. So what I can do is I'll simply go for the IntelliSketch, select the midpoint. Now go for the line option. Select the line of thickness 0.13, black color, and then complete the hexagon. So this point to this point, and midpoint of this point, this point, midpoint, then back to this point. So I get the hexagon. So let me just connect these. So this is how I complete the frustum of the hexagon. So which all edges are visible, only that will darken. So this edge is visible, this slant edge is visible, correct? This slant edge this base of the pyramid, this edge, this base edge, and this edge, top edge. So go for the line of thickness 0.50. So with this we complete the frustum of the hexagon pyramid. So now we need to construct the sphere. So we have got the axis line here, as you can see. So from here again, let me take the isoscale of length uh, 15, because the diameter is 30. So this is ISO 15. So I'll be having this line as it is for reference. Now let me consider constructing the conversion of this entire hexagon into the isometric scale. So go for the scale option, change this into the ISO scale. So you can just see that the entire thing is not selected. Okay, so now we can convert the scale option 0.816. So please remember that you're converting it to the scale after drawing the isometric length of 15 mm, that is the radii of the sphere. So now go for the circle and draw the circle of diameter 30 mm, keeping the center point as that ISO 15 mm. So convert this into 0.50 and you get this. So this part of the hexagon will be invisible to the observer. So change it to 0.13 and let me select the split option. Select this line and split it at this point. Correct. So I get this as a separate entity. So let me go for the split option. Select this entire edge and split it at this point of intersection. So change this to 0.13. So this is how I get the sphere resting on the frustum of the hexagonal pyramid. So go for the angle between, show the angle, so which is equal to 30 degrees. So this is how we construct the hexagon, the frustum of the hexagonal pyramid, and then the sphere. So you can just see this is the orthographic projection of the combination of the frustum of the hexagonal pyramid and the sphere, and this is the isometric projection. Thank you all for watching.